For centuries, the ocean has kept its deepest secrets. We've mapped its floors and pulled life from its depths, but the minds of whales remain a profound mystery. Their songs, complex melodies that travel for hundreds of miles, are not just random noises. These are the sounds of families, of cultures, of ancient lineages stretching back before humans. The songs of the humpback whale, with their repeating themes, feel almost like a form of art. The powerful clicks of the sperm whale form rhythmic patterns, a clear form of communication. What are they saying? Are they telling stories, warning of danger, or expressing love? The mystery of whale communication challenges our assumptions about language and intelligence. Listening to them is humbling. It reminds us the world is full of different kinds of minds. To decode their language would be like making first contact with an ancient civilization hidden beneath the waves. Recordings of whale songs in the 1970s captured the public imagination, transforming whales from hunted creatures to symbols of intelligence and conservation. The quest to understand them is, in many ways, a quest to understand ourselves. The journey to understand whales began with patient observers in small boats, armed with hydrophones and tape recorders. In the mid-20th century, researchers like Roger Payne and Scott McVeigh were pioneers, recording and studying humpback whale songs. They discovered the songs were structured with repeating themes, much like human music. All the males in a population would sing the same song, evolving it over a season. But the meaning behind the sounds remained elusive. Scientists could identify patterns, but the code was unbroken. Analyzing the sounds was painstaking, listening to hours of recordings, inspecting spectrograms, and categorizing sounds by hand. The sheer volume and complexity of whale sounds overwhelmed the technology of the day. Despite these limitations, their work proved whale sounds were a sophisticated communication system. Their recordings changed public perception, inspiring a global movement to protect whales. They opened the door for future research, setting the stage for a technological revolution. The code remained unbroken, but the world was finally listening. Understanding whale communication was uniquely challenging. The ocean is vast and opaque. Whales spend most of their lives underwater, far from human eyes. Their low-frequency calls travel for hundreds of miles, making it hard to link sounds to specific individuals or behaviors. Whale vocalizations are nuanced. Tiny changes in rhythm or frequency may carry meaning. Past efforts were like trying to learn a language by overhearing random words in a crowded train station. Researchers rarely knew who was speaking, to whom, or what was happening at that moment. This lack of context made the sounds just data points without meaning. To crack the code, scientists needed to track every whale, every sound, and every behavior simultaneously. This required a technological leap, massive, multi-layered datasets, and powerful analytical tools. The challenge was immense, but the dawn of artificial intelligence brought new hope. AI offered the possibility to find hidden patterns in the chaos. The dream of understanding whale language was no longer out of reach. The breakthrough came from artificial intelligence. AI, especially machine learning, can analyze complex patterns just as it does with human language. Scientists wondered, if AI can decode human speech, could it do the same for whales? The idea was to treat whale communication as a true language, letting AI learn patterns from massive datasets. Machine learning could detect subtle correlations invisible to humans, identifying the basic units of whale speak. Instead of asking what a specific sound means, AI could map the entire structure of whale communication. It could analyze context, sequence, and behavior, moving toward genuine decoding. AI could process in hours what would take humans decades. By cross-referencing sounds with behavior and environment, AI could build a whale dictionary from the ground up. The dream of understanding whales was becoming a concrete scientific project. Technology had finally caught up with our curiosity. To teach AI a language, you need a massive library of examples. Project CETI, the Cetacean Translation Initiative, set out to gather the largest dataset of whale communication ever assembled. Focusing on sperm whales in Dominica, the team used hydrophone arrays, drones, and innovative recording tags attached to whales. These tags recorded sounds, depth, orientation, and movement. providing a whale's eye view of their world. For the first time, researchers could link specific sounds to individual whales and behaviors. Drone footage and synchronized sensors created a detailed picture of whale social life. All this data, sound, video, location, was time-stamped and synchronized. Feeding this mountain of data into AI was the next step. The AI analyzed spectrograms, identifying and categorizing every click and coda. The goal, billions of codas, each linked to a whale, a moment, and a behavior. This context-rich dataset became the Rosetta Stone for translation. Once the data flowed in, the AI began its silent work. Early findings were staggering. Sperm whale communication is combinatorial, using discrete click patterns as building blocks. The AI identified a phonetic alphabet of codas and began to uncover the grammar behind their use. Certain codas followed others, suggesting syntactical rules. Tiny shifts in tempo and rhythm, once dismissed as noise, proved crucial, modifying meaning like adjectives or adverbs. The AI mapped dialogues, showing whales take turns in conversation, not talking over each other. It linked specific coda patterns to context, like a rapid coda for mother-calf reunions. Another complex sequence was common among adult males in groups. While not yet translating to English, the AI was building a functional dictionary. It was associating phrases with observable social contexts. This was the first step from describing the language to understanding it. The AI revealed whale communication is more intricate and alien than we imagined. Meaning is highly contextual and multi-layered. A single coda changes meaning based on who says it, who listens, and what's happening. There's no simple translation for each sound. Whales don't use nouns for objects. Instead, they describe relationships, actions, and situations. Their language is about process, not static things, a language of verbs and adverbs. Conversations are non-linear. Whales can carry on multiple threads at once, layered by rhythm and tempo. It's as if they're in several group chats simultaneously. These discoveries force us to rethink our definition of language. Theirs is a language suited to a three-dimensional, fluid world. The AI didn't just translate sounds, it opened a window into a different way of thinking. Our anthropocentric biases are being challenged at their core. These findings have profound implications for conservation. Losing a pod means losing a unique dialect, a library of knowledge, and a culture. This adds urgency to protecting whales and their habitats. By listening to their conversations, we can understand what stresses them, like ship noise disrupting their communication. This evidence supports quieter ships, rerouted lanes, and acoustic sanctuaries. Beyond policy, this breakthrough deepens our empathy and connection. It's harder to see whales as resources, and easier to see them as a fellow society. Understanding their language could lead to direct interventions, like warning whales of danger in their own language. While such applications raise ethical questions, they are now within reach. Project CD and AI have given us new tools to protect the ocean's giants. The more we understand, the greater our responsibility to ensure their survival. Decoding whale communication is just the beginning. Project CD's methods can be applied to dolphins, elephants, and other vocal species. Each species holds a unique perspective, a different form of intelligence. AI gives us the key to unlock these other minds. This new era of interspecies communication will challenge us to confront our impact on other lives. We may learn of their fears, joys, and needs directly from them. This knowledge could spark a revolution in animal welfare and environmental law. We must proceed with humility. The goal is to listen and learn, not control. The promise is a richer understanding of life's diversity and our place within it. For the first time, we can do more than listen, we can understand. The voices of the deep may teach us how to be better inhabitants of our shared world.